So the question started out as you borrow $500, okay? And you promise you're going to pay it back $15 a month, okay? And I asked you to make a table. And to make a table specifically of how much you still owe after each payment. So at month 0, right after you borrowed the money, you still owe $500. A month later, you give $15 to the person you borrowed from, well, assuming we're not talking about interest or anything, you now only owe $485. The following month, you give another 15. It reduces how much you owe. And it happens at a constant rate, which is why the problem actually says a rate of $15 a month. That's the rate of change, right? The rate of change of how much you still owe. Okay? And so every month, you're adding a negative $15. Right? You're paying back. Then the next thing it says to do is to write a recursive formula. Here's what I want to do. I want to make it clear what a graph here, like this one, okay? Right. In order to have a recursive formula, right, you started out owing $500. After 1 month, I owed $485. After the next month, I owed $470. Okay, if I was talking about a recursive formula or a recursive description to get to the next point of this line, I would say you start here at 500, and then you go 1 to the right and 15 down. Right? That's what it says. That's recursive. You go 1 to the right and 15 down. You go 1 to the right and 15 down. You go 1 to the right and 15 down. Now, if I asked you how much would you owe after 12 months, bless you, that doesn't quite help you unless you want to start from the beginning and keep going step by step by step until you get to 12. But here's the deal with the recursive. It doesn't tell you exactly what your answer is, but it tells you what steps you have to take from the very beginning to get there. So the downside with a recursive formula is that if you lose your place, you have to go back to the beginning and start all over. And you have to go through every step to get to the answer you want. On the other hand, the good news is it's pretty easy to explain it based on the description of the problem, right? You're borrowing 500, so how do we write that? Well, the first entry, the first term is going to be $500, okay? The next term is going to be this one minus 15. Then after that, we're going to take that one and subtract 15. For each entry we do, right, whichever one it is, right, we have to take the entry that came before it, okay? Now notice that here, this is talking about all of the A's are the entries. This is an A, A0, A1, A2, A3, A4, A5, A6, okay? For each entry, no matter which number entry you've got, right? If I want number 6, I have to look at the entry that came before it, which would be 6 minus 1. So that's entry number 5. And then I have to subtract 15 from it. Okay? This is a recursive formula. It takes 2 entries. One of them is your starting point. And the next one is the description of what you do from point to point to get where you're going. Okay? That's the recursive formula. So for this particular problem, this is the recursive formula. If I want to do this, right, I'm going to start out at 500, and then I'm going to subtract 15 for the first month, subtract 15 for the second month, subtract 15 for the third month, subtract 15 for the fourth month, subtract 15 for the fifth month, dot, 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 subtract 15 for the nth month, right? I got to subtract a whole bunch of 15s. How many 15s do I want to subtract? Well, it sort of depends on what number I'm looking for. I don't want to do it for the 8th month because then you'll say to me, well, okay, how do I do it for the 9th month? So whatever it is, I'm looking for the nth month. General thing that tells you how to do it no matter what number you're looking for. The letter is what we put in there when we're trying to do a placeholder. And the thing is, no matter what number you're looking for, I don't want to say how to do it for the 6th month. That's how many 15s you're going to have to subtract. How do I do it for the 7th month? Right? Well, we have a way of saying that. Okay? If we have multiple subtractions here, then we're saying you're going to take $500 and subtract 15 n times. Okay? And that will give you the nth term in the sequence. A0 was 500, and the reason we're calling it A0 instead of A1 is because it's at month 0. It's before any time went by, right? Then after 1 month, I took this number and subtracted 15. After 2 months, I took the number from 1 month and subtracted 15. That's one way to figure this out. The other way is to say, look, I started out at 500. I've been paying you back for 6 months. 6 times 15 is what, $90. So now I only owe you 410. Makes perfect sense, right? This is the explicit one because this tells you exactly how much do you owe. This one tells you basically how to figure it out going over and over and over again, step by step by step. Remember, recur, right? Recur means to happen again and again. That's exactly right. And that's why you need 2 pieces of information to talk about this one, right? Because you need a starting point, and then you need the directions as to where to go next, okay? Let's do it this way, right? In a way, it's sort of like if this was a map, and I wanted to tell you how to get to this point right here, right? I could tell you to go east 500 feet, go south 500 feet, then go east 500 feet more and south 500 more feet after that. And you would say to me, what? You'd say to me, huh? Right? If I give you directions like that, where to go next, what to do next, what to do next, that's only going to work if I tell you start here. Then I'm telling you go here, go here, go here, go here. That's great. What's the other way I can do it? Well, I can give you the explicit latitude and longitude. Actually, this is latitude, this would be longitude, right? I'll give you the explicit point and tell you this is exactly where you need to go. Right? I could give you the address. I could say this is 16 Main Street. And you would say, oh, okay, I know how to get there. Wouldn't matter where you were. Or I could say to you, look, you're starting at Pally, so what you got to do is you got to go out the entrance, then you got to turn right, then you got to turn left, then you got to turn right again, then you got to go 3 more blocks and turn right. This is a recursive description, or more like a recursive description. For the recursive, specifically for these recursive descriptions, it's got to be the same directions over and over again. Okay? So it sort of has to be like a series of steps. Go forward 2 steps, go down 1 step. Go forward 2 steps, go down 1 step. Go forward 2 steps, and sooner or later you'll get there. Do that so many times and you'll get there.
If you're making the wrong step, you would have to go back.
You would have to, right. If you screwed up or lost count, you would have to go all the way back to the beginning to start all over again. Whereas if I told you the address, it wouldn't matter where you were. You could put it into Google Maps and it would tell you how to get there. You'd be able to find it. You'd plug that in. Does that make sense? Okay. That's what this is. If I tell you the directions step by step from a starting point, I have to tell you the starting point and the directions. If I tell you exactly where you're going by giving you the address, then all you have to do is plug that in here and it gets you where you want to go. This is explicit. This is recursive.
Just one more question.
Yeah.
Can you go over again the AN part?
Which part of the AN part?
The beginning AN equals AN.
Right here?
Yeah, just that part.
Okay. All this is, AN, right, the N stands for a number. I want to know, how much do I owe after so many months? How many months? I don't know yet. I haven't figured it out, but I just want to know, how can I figure it out? How can I figure out after, I don't know, 12 months? How can I figure out after 12 months how much I still owe you? Well, there are 2 ways to do that. And it doesn't matter whether it's 12 months or 9 months or 8 months. There are 2 ways you can do that. Take the number of months you're talking about, okay? However many it is. Start out with how much you owed in the first place. And then for whatever month you want, go to the month before it and subtract $15. And you'll say to me, well, how do I get the month before it? Well, you got to go to the month before that and subtract $15. Okay, so I want to know, how much do I owe you after 12 months? Well, that's easy. Figure out how much you owe after 11 months and subtract 15. Well, how do I figure out how much I owe after 11 months? Well, that's easy. Just figure out how much you owe after 10 months and subtract 15. Right, but how do I figure out how much I owe after 10 months? Right? If this is 10, well, that's easy. All you got to do is figure out how much you owe after 9 months and subtract 15. Sooner or later, you're going to get bored with that. You're just going to get annoyed. Is there another way to do that? Well, yeah, actually there is. Pick the number of months you want to know after 12 months, right? Start with your starting point, and then subtract 12 15s, but instead of subtracting them one at a time, multiply 12 by 15 and then subtract that. Okay?
So multiply negative 15 times 12 and then subtract it by...
And subtract it from 500. I mean, think about it for a minute. You've been paying me $15 a month for 12 months, right?
Yeah.
How much have you paid me? I don't know. 30, right? $180. You paid me $180 already. Right? Pretty cool. How much do you still owe me? Well, I don't know. I got to take the 500 and subtract 180. Oh, so I still owe you $320. Yes. Okay? So that's what's happening here. What's happening here still gets you the same answer, but you got to start off by saying, okay, 500 minus 480 minus 15 is 485, minus 15 is 470, minus 15 is 455, minus 4, right?
Yeah.
Until you can get to the 11th month so that you can subtract 15 more from that and tell me the 12th month.
I got it.
Cool. Anybody else? Okay. These are 2 different ways to describe this function. in addition to the verbal description that's on the board in the first place and the table that's here. The fourth way we know how to describe a function is with a graph. Why is a graph useful? Because what I really want to know is, how long is it going to take me to pay this off? Okay? How long is this going to take me to pay this off? Well, one way to do it would be to just keep sitting here subtracting 15 on my fingers until I get to 0. Right? Another way would be to set this equal to 0 and then solve for n. Right? At what point will this be 0? How much I still owe? Or, if you can make it a graph, you can plot it, and after you've plotted a few of them, you say, oh, look, this one's a linear graph. Why is this a linear graph? Well, one reason is because it's a line. It's a straight line. Okay? Another reason is, what kind of sequence is this? Right? Arithmetic. And why is it arithmetic? It's because a constant is being added to it as opposed to multiplied to it, right? You start somewhere and subtract the same number over and over and over again, or add the same number over and over and over again. That makes it an arithmetic function, arithmetic sequence, which makes it a linear function if it's a function, and it is, right? And so that means I can draw a straight line, and I can go all the way down to here until somewhere between 33, and it just so happened that I just dumb luck. I made this so that I didn't have to go off the page. But right here, just before I get to 34, I get to 0. Now, does that mean that after 34 months I've paid you off? Well, let's see. In order to double check, because when I did it I wanted to make sure I was right, I went over here and I said, look, if I pay you for $15 for 34 months, how much will I have paid you? Well, $15 times 34, that's $510. Hey, guess what? After 34 months, we're done. After 33 months, not so much, because I'll still owe you $5. Right? The last payment, the 34th payment, should only be $5 instead of $15. Otherwise, I'm overpaying you. Okay? But how did I figure that out? Well, I didn't figure it out by repeatedly multiplying over and over again until I got there. I drew a graph. I literally drew a graph, drew a straight line, and sure enough, between 33 and 34, that's where it hit 0. All of this is the same story. It's me borrowing $500 and paying it off $15 a month. Right? Same piece of information, same story, same life experience, described 4 different ways. Actually, 5. One way is by table. One way is verbally, by description. One way is by equation, but we actually have 2 different ways to write the equation. And then the 4th way is by graph. Each way has its purpose, each way has its value, and each way is useful. And each time you do this, it's not just a math problem. You are actually describing something, or could be describing something that occurred in real life. The purpose in learning all the mathy stuff is to figure out how to apply it so that when you want to borrow $500 and pay it back $15 a month, you can use the most efficient method here to figure out whatever it is you want to figure out. You want to know how much do I owe after 6 months? That'd probably be this one. You want to know how do I figure it out? That'd probably be this one. You want to see it all laid out? That'd probably be this one. You want to see how it looks over time and figure out when you're going to be finished? That'd probably be this one. Each one serves a different purpose, but they all describe the same event. Questions? Cool.